Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Quick note before we begin, the Finding Genius Foundation, as part of the Finding Genius podcast, has recently completed a book about understanding viruses. So the creation of this book was to interview 100 virologists, ask them a lot of deep, difficult questions, take the most difficult questions, and then re-interview the top 25 or so and ask them the hardest questions I could think of. And we compiled that all into a book. So you'll see question and 4 or 5 experts' answers. Question, 4 or 5 experts' answers. There's about 30 questions in the book. I think it's a great read for the layperson and for the researcher. It talks about a lot of speculation in the world of viruses, such as are they alive or not, and why is it important? Why do viruses go latent or hidden or ineffective or sit in a person or an animal or another creature for weeks, months, years, and then suddenly become virulent and affect that person? So there's a lot of really provocative questions in the book. It's now on Amazon. So if you go to Amazon and type in Finding Genius, you'll see the book on viruses. It's also on Kindle. If you want to go and order it now, you can do so again by going to Amazon or Kindle, or go to findinggeniusfoundation.org and go to publications. There's an opportunity as well to get the transcripts of all the interviews and to hear the original interviews themselves. If we had put them all together, the book would be about 1,000 pages, but we condensed them down to make it juicy and concise and tight and very interesting. So I hope you'll check out the book. We're now working on one about cancer, but this is going to be our goal is 3 times a year to come out with these masterclass books that I think will inspire new scientific research, and I hope you'll check it out. Thank you. Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Camila Espejo. She's a researcher, part of the Tasmanian School of Medicine, College of Health and Medicine. And we're going to talk about Tasmanian devils and facial tumors that they get and some of the interesting implications of what happens to them. So, Camila, thanks for coming.
Thank you for having me.
Yeah, tell me about your research.
Well, so I work, as you said, with Tasmanian Devils. I'm a veterinarian, actually, from Chile. So what we do, my research basically focus on diagnostic approaches to try to find this disease before tumors appears in the devil. So basically, I go to the field a lot to collect samples from Tasmanian devils, and also a lot work into the lab as well.
Well, what are Tasmanian devils like? I mean, their name sounds scary. Like they'll go.
All I can think
of is the cartoon character, the Tasmanian devil. But what are they really like? What do they look like, and how do they act?
They are the largest living marsupial carnivore in the world. So they got displaced after the extinction of the Tasmanian tiger. Of course, devils are endemic to Tasmania, and they weigh between 7 to 12 kilos. They are actually very cute, I would say. They look more like a dog.
Okay.
Yeah.
Are they shy? Like, do they run away, or are they aggressive, or what are they like?
No, actually, they are very shy. People believe that I'm working with very aggressive animals, but actually I handle them a lot, and they are very, very gentle animals. So easy than a cat, for example. Especially in the wild, they are very shy because usually they are scared of you. However, when they are in captivity, they are a bit more aggressive. So then you cannot really handle them conscious. You have to anesthetize them.
Otherwise, why are they called devils, by the way?
Oh, this is because the title Tasmanian Devil came from the first European settlers who first entered to the States. So they start to hearing these mysterious screams and growls within the bush, and then they call them, Tasmanian Devils, because they scream pretty bad.
Oh, really?
Yeah.
Do they scream when you handle them? Like you're killing them or what?
They can. I have experienced that. However, usually when you handle them, it's very early in the morning. These animals are nocturnals, so usually they are sleeping when you handle them in the morning.
Okay. Do you go out to see them at night or only in the early morning?
In the early morning. So basically, I can explain you a little bit how is the field work. So what you do is we go one day and set about 40 traps, that they are special traps for devils. They are like a big tube, a kind of a pipe. So then you put a bait, which usually is a lamb, for example. And then they go into the night and they enter to the trap. And then in the morning, you go to check all the traps. And then you check if it's a devil inside or no. And usually what you do is you put them into a Hessian bag. And then you weigh them, you microchip them, you take many different kind of samples, and then you release the animal. And usually, even if you don't believe it, sometimes when you are taking blood from them, they are snoring.
That's funny.
Yeah.
But you anesthetize them. That's why they're snoring? Or...
No, they are. No, I do not. Conscious.
Oh, really?
Yeah.
Wow.
Conscious. Yeah.
So I guess they don't feel pain or what?
Well, the way that you handle them, you restrict them really well. As a person that, of course, knows how to do it. You are trained to do that. And also what you do, the samples is nothing so painful. So it's just a little bit of a blood sample, weigh them, sex them, and all these health checkups.
Okay. Okay, let's get into the tumor part. So why do they get tumors and why do you study them? Why are they important to you?
Yes. Tasmanian Devils in 1996, a wildlife photographer noted a really big tumor. And then they start to investigate that, and they realized that this disease was basically reducing and killing so many animals in the wild. So this is why devils, they got into the category of risk of extinction. And then 80% of the population reduced because of devil facial tumor disease. And the disease is something incredibly fascinating because they have these tumors, right, that they are transmissible. So it's basically a cancer. So they have big tumors on the face, inside of the mouth, or on the neck that they transmit to another devil when they bite each other. The cell is transmitted, and then like a transplant, basically. So,
Do these tumors metastasize or
yes, they do. They do.
Are they
so
found on the saliva then? Is that why when they bite, they infect others?
No, they don't. They don't. People believe that they could be found in the saliva, but they don't. So still we don't really know when they are in the period that you cannot really see the tumor, how by biting behavior they are transferring the tumor. So basically, for example, imagine if a devil has a tumor, it's going to bite another and it's going to transplant one of the tumor cells into another devil, and the other devil is going to grow a tumor. And they die in approximately 6 to 12 months after tumors have appeared. And it's mainly due to metastasis and or starvation because they cannot eat as they have these tumors inside of the mouth.
That's terrible. Where does this come from originally, you think?
Yeah, no one knows. It's a clonal cell line that it's a neuron, like the origin of these clonal cells is a neuroendocrine cell, a Schwann cell, which are in the nervous system. So it's clearly some mutations that happen in one devil, and this tumor cell was able to be transmitted and survive in an entire population.
Okay, so I guess people have biopsied the tumors. Like, what have we learned about? Is it viral based? I mean, what can you tell from the tumors as to what's going on? What have you learned about them?
No, well, at the beginning, people believed when they discovered the tumor that there was a viral infection. However, it's not. So there are not many transmissible cancers. Just like, as I say, as a tumor cell is transferring to another individual, there are not many in nature. So there is another one in dogs which is transmitted sexually, and Tasmanian devils, and also there are some leukemias that they are transmitted in clams, in soft shells, but that's it. It doesn't exist another transmissible cancer. So usually what we do and this is how my research came along as well.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
We diagnose the disease by visual appearance. They are really easy to distinguish. You can say this animal has DIPT-D, yes or yes, because the tumors are very distinct. And then to confirm if it was DIPT-D, you take a biopsy, a tumor biopsy, and check in the lab with PCR techniques or immunohistochemistry. However, we know that devils have a latent period in which they don't show tumors for about 1 year. So they are incubating the disease for up to 1 year, and they could be transmitting the disease.
So you say they're not in the saliva, but yet they're transferable. Are you looking for tumor cells in the saliva, or you're looking for like extracellular vesicles, or it's got to be some method of transmission?
Yeah, probably this part, we don't really know how is the method of transmission when they are in the latent period of disease because they still don't have a tumor, right?
Well, here's a quick question. Who does the biting? The person, the devil with the tumor, or what if you have a healthy devil that bites a sick devil? Will it get it? Or
exactly.
Does it go both ways?
Both ways. Yeah. And what happened is these animals, they bite each other so much, especially in the mating season, because when they are mating, they are very brutal. So they bite a lot because of competition with other males or when they grab the female. So it could be both ways, as you say, a healthy devil bite an animal with a tumor, or an animal that is already have the tumor bites the healthy one. So both ways.
Do the ones that have tumors still want to mate? Or like what happens to them?
They
I know
do.
after a while they can't eat, but otherwise are they normal up until they become adulthood?
They are normal, and this is quite amazing that you see animals with big tumors in the wild and they are still doing their job. They are still healthy in a way, but then of course you go again to the wild and then you see the animal skinnier and progressing with the disease. Yeah.
So what are your hypotheses on how this is transferred? What are you looking for in the saliva? It's got to be something.
I'm not looking in the saliva. So to identify if we can detect this disease early, before tumors appear, what I do, as you say, is using extracellular vesicle approaches. So we take a blood sample, usually it's a prick in the ear that we do to the devil, and then we use the serum. And then on that, I investigate the extracellular vesicles. And what I had, it was horizontal samples, so animals that they were healthy. And then 3 months or 6 months later, I diagnosed them with DIPT-D in the wild. So we know that at the moment that they look healthy, they weren't really healthy because they were incubating the disease. And what I have found is one marker that is able to distinguish that devil is already incubating the disease. That is a protein that is present in the extracellular vesicles 3 to 6 months before they develop tumors.
Well, maybe the tumors on the face are the last ones to appear or later ones.
Definitely.
Have you tried to put them under an MRI if they're in that incubation stage to look if there's tumor burden already inside?
You mean when you take a biopsy?
Well, yeah. If you have a devil that now tests positive for this disease, but it looks perfectly fine, maybe internally, maybe the tumors have started inside, around several organs or whatever. Maybe the face is later, so maybe there's a shorter incubation period than you think. I don't know.
It could be. I think what is happening is they have a little bit of cells that they are trying to progress, but probably the devil immune system as well is trying to fight. So it takes a while to establish this tumor.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
So actually, the markers that I found in the extracellular vesicles, we believe and hypothesize that it's a host response. It's not something that is coming from the tumor. It's a response from the devil that is, as they have this clonal tumor cell, apparently, all the devils, because I did a large study, they are reacting in the same way, no matter how many cells they have already growing in their bodies. And this protein is an antimicrobial peptide that has been found in humans as well that could have some mechanisms against cancer.
What tropisms do these tumors have? I mean, obviously the face, but where do they tend to metastasize to? And maybe that would tell you something about them. You know, if they tend to go to the same place first after the face or before the face, you might be able to track back their history and where they came from.
Yeah, usually they tend to go when they metastasize to the lung, spleen, lymph nodes. Those are the places that they tend to go. However, it's something that needs more study because the study that I'm talking about is quite old. And this disease is evolving in the wild as well. So it's changing the pattern, how it's behaving. So yeah, so it's challenging to know exactly where it's metastasizing, because you cannot really do necropsies on those animals or take an X-ray, because they are in the wild. So it's challenging in this sense.
Well, what do you mean? Why, if you're tracking them and then the tracker stops moving, meaning it's dead, how come you can't go grab it quickly out of the wild and then, look at it, do an autopsy?
Well, you can. There are people that put collars and do that. However, it's a really expensive and time-consuming thing. So, yeah. It's not easy either to find an animal that just died quickly that you can necropsy. Even though, of course, we do some necropsies of animals, for example, that they are coming and they are found in really bad stage, and you can do that. But however, the numbers is never going to be enough to make a conclusion and say, yeah, this is exactly the place in which DFTD metastasized.
So maybe a key would, has anyone tried to make an organoid, sample some of the tumor cells and try to culture it, in a lab and see if you can grow it?
We cultured that in the lab. They grow pretty well, actually. Yeah, and then there are people that, for example, I cultured them in the lab, and then the first step, I realized that they do release extracellular vesicles. So I characterized them. And then I found that the extracellular vesicles that they release, they have many proteins that they are related with metastasis. And also I could find some key molecules because something that I forgot to mention, but these animals, unfortunately, they don't just have one devil facial tumor disease, they have two different ones that they are genetically distinct. So they have one that it was found in 1996, which is called devil facial tumor disease 1. And they believe that it was is coming from a female devil. However, in 2014, it was discovered a second one that is named devil facial tumor disease 2. And this is just confined to a region in Tasmania, which is contained by natural barriers. But it's a different tumor, which started in a male devil. So they are very unlucky creatures, actually.
Well, if you compare the extracellular vesicles that you find in devils that don't have obvious tumors versus ones that have obvious ones that come, from the tumor cells, what's the differences?
Well, the ones that you compare with the ones that they have obvious overt disease, tumors, the extracellular vesicles they have proteins that they are related with metastasis and with progression of the disease. So usually some indicators of the disease is progressing, especially when they have large tumors in comparison with the animals that they are just in latent stages of the disease. However, the protein that it was able to diagnose when they are, or distinguish animals that they are latent stages of the disease versus the healthy controls, this protein is still as well upregulated in animals when they have visible and big tumors. No matter what size of the tumor, this protein is up all the time.
So the extracellular vesicles are, what differences do you observe? What does that tell you about the tumor? Has it really not been helpful?
Well, the most important thing that for me is to have found a preclinical biomarker in which you can tell when the animal is infected with the disease before tumors appear, which is something that has been trying to do for so long in order to put or to create good conservation measures into the wild, because if you have an animal that hasn't developed the tumor yet, for example, you can really know which animal to put into insurance population, because this is one of the measures that we do, is to keep animals healthy in different places of Tasmania in case the Tasmanian devils go extinct. So we know which animal from the wild we can take and put it there because it's going to be healthy. Yeah, epidemiological studies, so you can really predict how DFTD can go, in the future years. Yeah, and also in the case that, for example, my group as well is working to develop a vaccine against this disease, you really need to know which devil was infected before developing tumors.
Can you treat them, or you just want to do a surveillance and see who's sick?
You can treat them, and this is one of the things that my lab group is working on. They are trying to develop a bait vaccine, so as a prophylactic therapy and also some immunotherapy things. So then at the end, if you really know what devil was infected, is really important to know if the vaccine was effective, for example, because imagine if a devil was incubating the disease and they have the vaccine, but the vaccine was unsuccessful, it was because of that, and then this tool wasn't available before. So this is how extracellular vesicles, they have been very useful with devil facial tumor disease.
Okay, so I don't know, do the Tasmanian devils contribute, how do they contribute to the ecosystem? Do they clear out certain animals that are otherwise would, overwhelm the region, or what role do they serve ecologically?
Well, they are the apex carnivore in Tasmania. So as you say, if they go extinct, it will generate an imbalance in the ecosystem. And they play, for example, a critical role keeping feral cats at bay, because here in Australia, we have a really big problem with feral cats, that they are everywhere and they kill many native species. So there are studies in which we know that the numbers of devils scare cats, so cats reduce. So if devils go extinct, probably cats are gonna increase the numbers, and this will be devastating for the ecosystem.
Okay. What do you think is next for your research, and over what time period? At what point do you think that? Do you feel like you're close to a breakthrough in understanding in any facet of it, or what are your thoughts?
Well, I think the next step in my research is, now that we found this preclinical biomarker to diagnose DFTD in preclinical stages, the next step is to develop a test, actually a diagnostic test, because now we just found the biomarker using mass spectrometry techniques, which are very expensive and time consuming. So now the next step is to put these tests down and do a more scalable and cost-effective test for Tasmanian devil. So I would love to keep working with Tassie devils, because I think they are fascinating creatures, and you can learn a lot actually about their cancer and apply this knowledge into humans as well, other species as well. So yeah, I think I would love to keep working with Tassie devils.
Okay, well, very good. Where can people find out more about your work? Where should they go?
Well, they can go to a paper that I have in bioarchive now, which I talk about how the extracellular vesicles that they are coming from the tumor cells, they have they are enriched in proteins that they are linked to metastasis. I'm also an early career representative of the Extracellular Vesicle Society in Australia and New Zealand. So yeah, I mean, they can contact me on Twitter, Camila Espejo, And yeah, happy to keep talking about this.
Okay. Well, very good. Camila, thank you for coming on the podcast. And I know maybe it's an arcane or strange issue to some, but it definitely has implications in terms of cancer and other areas. So thank you for being here. I appreciate it.
Yeah, thank you to you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.